Hello everyone, True Zero Emissions here. First thing I want to say is check out Rumble Motors, R-U-M-B-L-E. Rumble Motors Blixt, I think it's Blix. Is it Blix or Blixt? Batteries, it's a graphene battery. You can order those batteries. I think those batteries can be ordered separately from their scooters, from their electric bikes. But double check that. Those batteries can take, those graphene batteries can take an 80 amp charge and even up to, if I understand correctly, 120 amp charge for less than 20 to 30 minute charging time periods. And they're safe, low cost to make, and I was introduced to the technology over 20 years ago. The only thing that's needed is for people to be aware of it and to know that the technology is ready. It's ready for your demand. So if you demand it, it'll be here. Don't forget that if we think back to the fuel cell water-powered car, that was said to be going to require large amounts of money and that it was not practical to make that work, and they still were able to achieve it. And now you can I don't know if you can buy, but you can lease and possibly buy fuel cell cars now, which turn hydrogen into electricity, right? If I understand correctly, but double check that process yourself. I think they're converting hydrogen into electricity. So you pay for the hydrogen and then you get your electric car powered from the hydrogen through a cell, right? That cell was very expensive to develop. And if that kind of money was put into graphene, which will be done if people support it, meaning to ask for it. Supporting is just asking for it, requesting it. And I'm looking into buying that technology myself, the graphene batteries, because it can take a really fast charge, which interests me. So for all the manufacturers out there of micromobility and electric scooters, look at the graphene batteries. The hobby industry of like electric RC cars, like 1/10 scale, 1/8 scale, and that whole entire industry is mixing graphene, I think, with lithium. Now, when I say it that way, double check on how they're doing that exactly. Maybe it's not correct to say it mixing. Maybe they're using parts graphene and other parts non-graphene and still using lithium. I just read very little about it, but what I know is that it's not just the graphene. I think that what Rumble Motors is doing is using an entirely graphene battery. I still have more to learn about it, but I want to just mention it to you to look into that. So this video here, we're looking at the wimshurst machine, and I wanted to point out a few things about this. This wimshurst machine, and just looking at wimshurst machines altogether, I'm noticing that there's something that keeps coming up in my study of how coils work and how coils interact with the environment, right? This energy-rich environment. And it seems like there has to be, for the most efficiency, there has to be, for example, I'm trying to think of, like, when I think of John Bedini's window motor, right? It was said to me that we want two magnets passing, now I don't know if I understand this correctly, but double check this for yourself. My image that I have, and I'm not sure it's correct, but is having two different magnets, right? Passing two separate coils. Well, yeah, two separate coils that are connected together. So two coils in two different places that are connected together. So those wires are connected together, that those coils are connected together, and the other end of them can go to a full wave bridge rectifier, right, to give us DC if we want to charge batteries. And then having the magnets that pass those two coils at the same time can be a north and a north facing the coil, a north and a north facing each coil, or a north and a south, and we'd have to test each of those. But what that reminds me of is looking at the wimshurst machine. I'm thinking to myself, so my friend Cameron and I were looking at the wimshurst machine, and we were doing some experiments the other day, and I was running this machine, and you can see a little spark there. It's kind of neat because it's a very small spark, right? But if I increase the space between there, I can go up to 8 inches, and that will be a massive bolt of lightning going across there, and it is so loud. What we have here is counter rotation, right? So when we spin something in space, I noticed that when we spin a magnet in space, Cameron and I had done an experiment a long time ago. We were experimenting with the end machine theories and technology by spinning a magnet in space. That's an end machine, right? Just spin a magnet, like a speaker magnet, in space. And if you connect to the outer perimeter of it and the shaft, the center area, if I recall correctly, I think those are the two areas where we want to connect, we're going to get a positive and a negative if we spin one direction. Now, if we spin it in the opposite direction, I noticed that the meter would read an opposite reading. So that made me think that spin relates to charge, or plus and minus, right? So here we have counter rotation. I'm going to turn this slow so you can see this. Do you see how those two discs are spinning in opposite directions? So the wimshurst machine, which this is a beautiful, amazing example. In fact, one of the most beautiful machines I've seen from, you can look at Winky's workshop on YouTube channel. That's where this was created. And one of the things I loved about the machine was that the collectors are not touching the actual discs, okay? The collectors here. I think they're 3/8 of an inch away from the disc. There's a space there, 3/8 of an inch on each side. And that includes on the other side as well, which makes me think of this, just that there's a charge here that is in this area. It's not just having to touch this to extract the energy from here. These kind of poke into that energy field, right? And if we look at let me see if I can pronounce the word. I may be mispronouncing this, but I think it's methernitha, METHERNITHA. And I may be mispronouncing that and also misspelling it. Methernitha testatica. TESTATIKA. Or it could be CA. Testatica. Methernitha testatica. And I think it's, if I recall correctly, I think it's Paul Bowman, or Bauman, Paul Bauman. And please double check that name for yourself. I'm not sure if it's Paul Bauman. The last name sounds correct to me, but I don't know if the first name's, if I'm getting that correct. But the name of the machine, it resembles a wimshurst machine in so many ways. And it has the two counter-rotating discs. These plates here are aluminum instead of copper, and they go all the way in, right? So each plate goes all the way in. So there's more area, more surface area spinning in air, right? And they have many collectors. And I don't know if those collectors are touching the fields with brushes, or if they're just in that field the way these are, just near it, right? One of the beautiful things about the Methernitha testatica is, and that machine, by the way, powers an entire community, if I understand correctly. They've been interviewed many times. They have shared in great detail how their machine works. Even though when you watch the documentary, I'm calling it a documentary, it's 27 minutes, it seems like the narrator is, when he speaks, he's saying that it's not being shared. But if you look at the machine, clearly to me, the community is saying, this is our machine, go ahead and make one. That's what it says to me, because they're showing you everything that's there. There's nothing hidden. They could have easily wrapped those coils and things and made it all so you can't see what's happening in there. You can see everything that's happening. And they even tell you, these are aluminum, this is aluminum, these are the capacitors over here, and they have these really big capacitors. And it seems like one side's plus and one side's minus. And then they run it through a bridge. I think we can call it a full wave bridge rectifier, or some kind of rectification that converts or cleans the signal up to be a DC signal, right? So, so I'm thinking about those coils in the John Bedini experiments where we have this window motor, and I'm just speaking from my own kind of thought experiments, right? Because I'm still learning. I'm still a beginner myself, and I'm still learning. I need to set my sandwich down here. I was eating a sandwich, and I want to set it down somewhere. Give me one moment here. Because I was going to try to eat while I was talking, but I decided I want to focus on just talking in this video and sharing with you what I'm thinking about. So there was this YouTube video or something that was sharing about thorium. I think it was thorium, saying a small ball of thorium could meet all of our power needs for, you know, several lifetimes or something like that. And then there's always these, now I don't know if thorium's healthy for us to be around or not, but there's always these different metals and different chemicals and things that we're told, oh, this can meet all our power needs for, you know, hundreds of years. And what I understand is that space itself, just the space between my fingers right here, right? Even that much space, any amount, any space whatsoever. In fact, even the space that my fingers exist in, right? We don't think of that as empty space, but there's 99.999% empty space between the subatomic particles that make up the material universe, right? And I'm part of the material universe. So just space itself, right? Whether it be the space I exist in or space between my existence, right? Between my two fingers, for example, that space has access to millions and millions and millions of watts of energy, watt seconds, watt hours, watt seconds, whatever you want to call it. We could even say that the entire universe, the energy of the entire universe, is accessible to every part of space. Okay, so if you want to start thinking about, like Tom Bearden talked about, which is the engineering reality, this is one thing I think of. What do you want to do with the energy, right? Well, we want to do good with the energy. We don't want to do bad. We want to do good things. We want to help people. We want to bring people the things they need. We want people to have their needs met, right? They need food, water, and it needs to be healthy, the healthiest food, the healthiest water. And we want to learn how to think in like a clean, clear way, if I say it that way, right? We want to be able to work as a community together to build connection, to build relationship, right? That's what we have to teach ourselves, right? Because school doesn't necessarily have the time to teach all these things. Many of us do learn these things in school, but not everyone. I've spoken with many people, and we all have different experiences in school, right? Including the home life. We always get a different education in home, right? And a lot of the teachers will say, we don't have the time to teach all the stuff you're supposed to learn at home. But sometimes parents themselves didn't get the education they need on parenting. So there's always room for improvement, right? And we don't want to blame the parents or we don't want to blame anyone. What we want to do is find solutions and share them together. And that's what this is all about. That's what engineering reality is really at the essence of it is about, right? Is learning how to share kind of like the formulas of, I guess we can call it the creational secrets, which aren't secrets at all, right? If anything we focus on will be revealed to us through our experimentation and through our expression, right? Making videos is expression. So as we express and share, what can interfere with that is distractions. And it's very easy to get distracted. That's why I always say, if you want to make a YouTube channel or you already have one and you have to turn the comments off, that's okay. I had to stop new comments from coming in. People can still post comments, I think, but the comments are not looked at right now. And someday there might be someone that can compartmentalize, categorize, and sort through the comments. But my attention is right now on what I'm doing with my experiments and my own research. I appreciate all the support everyone has given and gives with their interest in the videos and sharing. And I want to thank you for sharing your attention with this channel by thinking about it and thinking about how you can build your life to be better than it is, right? To keep improving. That's what we all live for. We live for improvement, right? For improvement of understanding, for improvement of how to share what we know, for improvement of how to build relationships and better connections with our understanding and with others as well. So when I think of the wimshurst machine and I think of this counter rotation, right? I think of those two John Bedini coils as I was explaining them, where there's two coils connected together, right? We'll say there's a coil here and a coil here, and we'll say there's a rotor which spins, and there's two magnets on it, and as those magnets pass those two coils that are connected together, something happens there that's important, and I think that's important for charging batteries. Now that pulse that comes out of there, I don't think it's good for battery management systems. I think it can harm them, and I think what people do is they connect they bypass the BMS and go straight to the battery. Now what that means is, this is purely experimental and it's a thought experiment. I'm not saying you should do any of this, but I'm just sharing how I'm planning on doing experiments and also what I imagine may be done, right? Because people have shared this with me as well. Is that by bypassing the BMS, we have to watch and make sure that the voltage never goes beyond where it should be, especially with lithium batteries. So for example, if my battery charge is increasing because I'm running a system like I'm talking about with these coils, right? And if the coils are large enough and have a ferrous metal in the middle, and they're large enough that there's enough energy being excited, or how can I say this? There's enough energy being translated, cohered, and released into the coils from the environment, into the coils, into the battery, through a full wave bridge rectifier, right? Through full wave bridge rectification, which is really just these. That's just these, something like these things. These are like 40 or 50 amp. This is one that doesn't work. See how it says full wave bridges? So it's just something like this. This was purchased at All Electronics, which I don't think they're in business as a store now. I think they're online only now. But this is just a regular full wave bridge rectifier. It was like 250 volts at I think 50 amps, if I recall correctly. And that's what I was told, but it could be slightly different than that. And going into something like that and then going into the battery, right? Now the pulses can possibly harm the battery management system. So going directly to the cells may be one thing I'll test as something that's interesting to me and see if the voltage can increase. No, I would not be putting meters on those pulses to try to read how much is going into the battery. I would just be seeing, is my voltage going up or down? That's what I'm watching, right? Is the voltage increasing or decreasing? What's happening with the voltage? The voltage will tell me what the battery's doing, and the temperature of the cells will tell me what the battery's doing as well. With lithium batteries, I do not want those cells heating up. So when I look at the wimshurst machine, I think to myself, see, I would have expected that one of these discs would have one collector on it. And then on the other side, the other disc would have a collector on that side. But rather, right, and I'm seeing a relationship, a connection between what I'm sharing with you right now, or what I'm going to share with you, and these two coils, right, that are connected together and have two magnets passing them at the same time. There's something significant about that versus just one coil and one magnet, right? Although I think there's significance to that too, but the significance to one coil and one magnet, or one coil and a lot of magnets that are all, let's say, all norths passing that coil on a wheel, right? Because this is one of the things that John Bedini would do, is he had a coil, and I'm imagining a coil with like anywhere from 21 to 26 gauge wire, an approximation. I don't remember the exact numbers. And then a ferrous metal in the middle, which could be welding rods of a certain kind of material, right? I guess something a magnet would stick to, with welding rods in there, in the middle of the coil, right? And then when all these north poles pass this, and imagine the magnets 5 inches apart from each other. That's important, because between the magnets is where the charge actually takes place. If the magnets are literally continuous all the way around, like many electric motors are. There's a lot of electric motors that have continuous magnets all the way around. Even if it's north-south, north-south, north-south all the way around, that's not giving us space between the magnets for the battery to actually charge. That's my understanding. So we have to give it time to charge, right? Which is between the magnets. But even if we had many magnets every 5 inches apart, and let's say they're all north, or they're north-south, north-south, back and forth, either of those configurations, but one coil, right? Now, John Bedini did something unique. He would wrap that coil with many different wires, and like one of those wires might be a motoring wire that makes that wheel spin, while the other coils on there, or coil, or maybe many coils, would be the generators, right? So in that instance, let me think about this. Yeah, I still don't know how that's different compared to having two separate coils with a rotor, right? Let's say the coils are facing inward, right? And the rotor's spinning, and those magnets pass the the coils at the same time, right? How is that different? Now, there's two different kind of battery situations I'm thinking of. One is we're charging the same battery that's powering the circuit, right? The other is we're charging a battery with those coils. We're charging a battery that's not connected to the circuit. So I'm interested in both of those. But I think when we have two separate coils, and I'm not sure, you'll have to test this for yourself, that allows a better possibility in my own thought experiments based on my research and study. And I still have a lot of experimenting to do. I have to see what happens when I do the experiment. But that may allow the same battery that we're charging the circuit with to charge better versus having to charge a separate battery that's powering the circuit, that's not powering the circuit, right? But let's go back to the wimshurst machine and notice that if I compare these two coils, right, two coils laying down facing here, facing a rotor that spins, and there's two magnets facing those coils, they spin around, right? Now I'm noticing here that each side, if I say it that way, because this is one side, that's another side, right? But each side is getting two messages at the same time, if I say it that way. It's getting what I think of as a plus, and that's a pulsing plus, right? Because this is conductive, conductive, conductive. And notice that these brushes, right? These brushes, these neutralizers, these are neutralizers. The only thing that touches those plates is the neutralizers, right? These collectors do not touch. So how does this touch? This brush is connected to here, right? That's 180 degrees away from the other one, right? Exactly the opposite over here. And then turning this makes a difference, how this is turned, right? I noticed that turning it upward made the spark jump much further, including on that side, having it more up. See, that's the bar on the other side right there, right? So this is called a neutralizer, and it goes here to here, and then this metal bar goes across, all the way across to the other side, and connects there and goes there up to here, and then down to there, right? So there's 4 brushes touching, 2 on this bar and 2 on the opposite side. And the way that those are moved affects how much power is drawn into here to make that spark, right? So, and I keep those together for safety, because if I bring them apart, this thing can hold a charge, and if I touch it or get close to it by accident, they can reach out and spark and grab me. It'll shock me, and it's very, very powerful. So, and many people have been shocked with these by accident with these wimshurst machines. So imagine an 8-inch bolt of lightning, right? That's a lot of power. So, so I'm noticing here that we have this side collecting on each wheel, right? So if one wheel is plus and one wheel is minus, it's collecting both of those at the same time, right? I think of the 2 coils with the 2 magnets passing at the same time, right? And how that is there's something significant about that. I'm told that the window motor requires that too. It requires that for efficiency purposes. Now this side as well, what I mean is the window motor requires that there's 2 magnets passing. I don't know if it's 1 coil at a time or 2 coils at a time, but I think it's 2 coils at a time. There has to be at least 2 magnets and at least 2 coils being passed at the same exact time, and those coils I think require to be connected together. But please confirm all this for yourself and make sure you do your own experimentation to confirm what is possible. So just moving these around, centering these. These are the capacitors right here. It's just full of BBs in there. There's capacitors in there. These are the capacitors. So this is copper on the inside. It's inside plastic, right? And then there's BBs inside there. So I'm noticing, if I just look at what I'm seeing here, I'm seeing 2 counter-rotating discs, and this is reaching into both sides and going to this side, right? It's going into this capacitor. Now what's this? Now, do you think this capacitor is connected to that capacitor? It doesn't look like it is, right? Well, let me say it this way. That metal plate goes underneath here, right? It goes underneath. There's a screw that goes underneath. And then there's, I keep stepping on these wires. Let me just move this. Okay. So these metal plates here, these big washer plates, are not directly touching that metal. That metal's on the inside right there, okay? There's a plastic piece between, this is a container, a plastic container, and there's plastic between that metal plate and the metal inside this container, right? So let's move this. I'll show you right now. I'll move this away, and I can lift this away. See how I'm lifting this away? You see that? There's plastic there separating that. I mean, how amazing. To me, it's really amazing. And you see that bolt there? Now underneath here, yeah, so I was saying, really, to me, it's really amazing that this energy is traveling through, literally through this plastic, right? This charge is traveling through plastic. Because these two capacitors, I think that's part of what makes this work, is that there's a space between the BBs and the plate here. And then this plate is connected to the other plate. Those two plates have a wire going across to them, right? Now, there's also a washer. I can show you the one on this side. You see that washer right there? Well, on the other side, there's that same kind of washer. And there's a wire that runs across on the other side. Okay, this side doesn't have any wire. I don't know if we could see the wire on the other side.